Alright friends, welcome back. In this video we're going to cover section 1.6 of your textbook, and that talks about how to solve various types of equations. So without further ado, let's go ahead and get started. So here in example 1, the first type of equation we're going to talk about how to solve is a polynomial equation. And the general rule of thumb here, we'll write this at the top, is that since you have a polynomial, what you want to do is collect all your terms to one side so that you have a polynomial equals 0. And then you want to solve it by factoring and using zero product property. Okay, so we'll write that up at the top here. So what you want to get is you want to get a polynomial equals 0. And then after that you want to factor the polynomial. And then after that you want to use the zero product property, or the ZPP. Okay, and so I'll take you through the steps of that right now. So here in part A we have this equation here. And this is a polynomial equation because it looks like all of the terms in our equation look like a coefficient times an x with an integer exponent. And so instead of dividing both sides by anything here to start off, what we would like to do instead is just go ahead and collect all your terms to one side. Okay? And so what I'll do here to start off is just simply take away the 48x squared from both sides. And so we'll go ahead and rewrite this so that all the terms are on the left-hand side. So we'll rewrite this as 3x to the fourth minus 48x to the second is equal to 0. And it turns out that this equals 0 is going to be pretty important for how we're going to solve this equation. And so that is always going to be something you need to work towards, is getting that equals 0. Okay, so collect all your terms to one side. After you do that, we're going to go ahead and factor the polynomial here. So kind of going down our factoring checklist, we need to check for a GCF first. I do believe we have one here, and that GCF is going to look like 3x squared. Okay, and so when we factor out 3x squared, what we're left behind here with is x squared minus 16, and that of course is equal to 0. All right, and at this point we would want to go ahead and continue to look at our factorization here and decide if we can keep factoring, and here we can, because the x squared minus 16 is a difference of two squares. And so we'll go ahead and apply the factoring formula for that, factoring it into x plus 4 times x minus 4. And I believe that's all the factoring that we're going to be able to do. Okay, so what we're going to go ahead and use now is something called zero product property. Okay, so the fact that we have all of our factors being multiplied and it equals to 0 is a really important idea for being able to solve the rest of this equation, because if you think about it, whenever you multiply two numbers and it equals 0, what that's going to mean is either the first number is 0 or the second number is 0 or both. Okay, so in other words, zero product property says that whenever you multiply numbers and it equals 0, one of those numbers has to be 0 itself. So because we're multiplying three numbers here and we don't really know the value of any of these three because of those variables, we'll go ahead and set each of these equal to x and then solve these individually. Okay, so 3x squared is equal to x. If you were to, sorry, not equal to x, it's equal to 0. If you were to solve that, divide both sides by 3 and then take a plus or minus square root of both sides, you would find here that x is equal to 0. In that second case, we have x plus 4 equals 0. Just simply subtract both sides by 4 and you'll get x is equal to negative 4 there, so that's another solution. And then finally we have x minus 4 is equal to 0, add 4 to both sides, and we get here x is equal to 4. Okay, and so in this equation we do end up here with three distinct solutions. So we end up with 0, negative 4, and positive 4. In this next equation, we have something that looks like x to the fourth minus 16. I'm not going to do this one in its entirety because the steps are the exact same. I just want to point out something about its factorization real quick, is that some flags here that this is going to be one of your factoring formulas is the fact that you're looking at a perfect square number like 16, the fact that this is a difference of two terms, the fact that we have two terms to start off with here, and the fact that this exponent on the x is a 4. Okay, that is a tip that this is going to be the difference of two squares, and so you can rewrite this as two squares being subtracted. Namely, we have x squared being squared to get that x to the fourth, and we have 4 to get that 16. So if you were to factor this according to the factoring formula, it would be, regularly it would be u plus v times u minus v, but playing the role of u here is x squared. And then one's a plus, one's a minus, and then we'll take 4 and 4, okay? And that, of course, is equal to 0, all right? Now, the factoring is not done here, because if you continue to look at both of your factors here, you'll recognize that this x squared minus 4 is also a difference of two squares, okay? So it's the difference of x squared and 2 squared, respectively. And so what that's going to mean is that we can go ahead and continue our factorization of this equation and write this as x squared plus 4 times x plus 2 times x minus 2. okay? And so if we were to use ZFP here, we would get x is equal to -2 as a solution, x is equal to +2 as a solution, and we'll just go ahead and finish this up. If you were to go ahead and set this third factor equal to 0 and solve, then subtract both sides by 4, and you would get x squared is equal to -4. And then if you were to take a plus or minus square root of both sides, you would find that this is going to be the positive or negative square root of -4. And whenever we take a root of a negative number, an even index root, that means that imaginary numbers are going to show up in your solution here, okay? And so remember, we said the easiest way to deal with the exponent is to scratch out the negative and put an I out front, and then we know the square root of 4 is 2. So we end up with solutions here of plus or minus 2i as our other two solutions. So 2 imaginary solutions and 2 real solutions, okay? So whenever you solve a polynomial equation, the steps are the same. You just want to collect all of your terms to one side, and then you want to factor the polynomial as much as possible. I'm not going to do these next examples in their entirety because the steps are the exact same. You would just want to simply factor. So if you forgot how to factor, maybe go back and watch that video. You would want to factor these polynomials completely. It looks like they already have the equals 0 in both of these equations already done for you. So if you get some answers to these and you're curious about what the solutions actually are, then remember to check the content library on OneNote, or always feel free to ask me whatever questions you have. Okay. Example 3, find all solutions of this equation. This is a polynomial equation as well, and I just want to go ahead and talk about the factorization of this because it's handled in the exact same way. You would want to factor it and then use ZFP or ZPP. Some people call it the zero factor property, so sometimes you might catch me calling it the ZFP, but it's the exact same thing. So here what we would want to do is, since we have a 4-term polynomial, in order to factor this, we would want to factor this by grouping. So we would want to group together the first 2 terms and group together the second 2 terms, and then look for GCFs in this group, in these 2 groups, and pull them out. So in the first group, I believe you'll be able to find a GCF of x cubed. That'll leave behind x plus 2. In the second group, I believe you'll be able to factor out a -8, and that leaves behind x plus 2. And so you'll happen to notice here that both of these groups have the exact same expression that they are left over with after you pull out the GCF. So what that means is, for these 2 groups, that x plus 2 is a binomial that both of these groups have in common, so we can go ahead and factor that out, all right? And so I'll go ahead and factor that out. That will look like x plus 2 that I factor out of both groups, and that leaves behind, of course, the x cubed minus 8. So x cubed minus 8 there. Okay. Now, if you look at your factorization here, we could just skip straight to ZFP, but if we did it right here at this step, then we'd miss out on some solutions. What we should do instead is really try our hardest to make sure that we're recognizing those factoring formulas when we see them, and I think we definitely have one right here. This is the difference of 2 cubes, okay? And so I'm not going to go into too deeply how this factors up because we already have another video that covers that. I will just share with you here that the x cubed minus 8 will factor into the x minus 2 times x squared plus 2x plus 4, and that is all equal to 0, okay? So that is as much as this polynomial will factor, and so at this point we would want to go ahead and skip straight to ZPP, saying here that we are multiplying 3 quantities, and we don't know the true value of either of these 3, but we know that when we multiply them together, it all equals 0. So that's why we're going to set each individually equal to 0 and solve. I'm just going to do those first 2 mentally. X would equal -2 here, and x would equal +2 in the second factor. But in that third factor, that is actually something that does not continue to factor, so in order to solve that, you would have to use quadratic formula, okay? I'm just going to go ahead and point out what's playing the role of A, B, and C here. I'm not going to go ahead and show you the quadratic formula because we have another video focusing on that. But here I'll share with you that once you are done with all the work, you should be ending up here with some complex solutions. And those will look like -1 plus or minus I times the square root of 3, okay? And so we end up with 4 solutions here, 2 of which are real numbers and 2 of which are complex numbers. So if you guys are needing help on your quadratic formula or your factoring, always feel free to come see me. All right, here we have yet another example of a polynomial equation. I'm not going to go ahead and do this one because it would get solved in the exact same way as the last one. You would just want to collect all terms to both sides, or one side. So namely, you would want to bring this -6 over to the left so that you get equals 0 there in your next line, and then you would factor that in the exact same way as the last example and continue by using the zero product property. Okay. This next type of equation is going to be radical equations. So these are going to be equations where there's going to be some sort of expression under a square root or a cube root, and we just need to remember how that's solved. Okay, so the basic steps are you want to get it by itself, so you want to isolate the absolute value, or sorry, not absolute value, goodness, that's later. You want to isolate the radical expression, and then you want to undo the radical expression. And you're going to hear me say that a lot in this video, right? So first step is isolate it, get it by itself. The next step is to undo it, or in other words, get rid of the radical, or later, get rid of the absolute value, or whatever it happens to be. Isolate and then undo is a very classic method for solving algebraic equations of many types. And so that's what we'll do here on this first example. So we have the square root of x plus 2, goodness, I'm having trouble reading tonight. This is the square root of 2x plus 8 minus 2, and then that equals 0, right? So the first step is to get the square root expression completely by itself. So we have this minus 2 that's hanging out on the left-hand side that we want to go ahead and undo. And we're going to just simply do that with inverse operations. So we're just going to go ahead and add 2 to both sides. And that's going to leave us with the square root of 2x plus 8, and that is equal to 2, okay? It's at this point that we would want to go ahead and square both sides. So we would want to go ahead and square the left-hand side, square the right-hand side. The reason that we're doing that is because remember that raising a square root to an exponent of 2, those are inverse operations, and it just leaves you with what was underneath the square root. Okay, so we're just going to be left here with 2x plus 8, and that's going to be equal to 2 squared, and that is equal to 4. Okay, continuing here, this is just a simple linear equation. I'm not going to demonstrate the next couple of steps for this because I would expect my college algebra students to know how to solve the rest of that, but it's basically handled in 2 more steps. Add 8 to both sides, divide by 2 on both sides, and you will end up here with x is equal to -2, okay? I do encourage you guys to be checking these solutions, by the way. We've covered in a previous video how to take your solutions for equations and check them in the calculator using the store function, okay? So that is always something I expect you guys to kind of get into the habit of doing so that you guys are confident about the answers that you're providing. Here we have a cube root in this next equation here. So we have the cube root of 4x minus 1 plus 2 is equal to 0. We're going to start this the exact same way. We would really like to begin with having the square root expression by itself. So we need to get rid of this plus 2 that's hanging out there in the back. And we're just going to use some inverse operations to go ahead and do that. We're going to subtract 2 from both sides. And that's going to leave us with the cube root of 4x plus 1 on the left by itself, isolated. And that's equal to 0 minus 2, which of course is -2. Okay? It's at this point that we want to go ahead and get rid of this cube root, and remember the way that we do that is we raise that side to the power of the index, which is 3. But whatever do to one side, you got to do the other side, of course, here. So we're going to go ahead and do that to both sides. On the left-hand side, we're just going to be simply left with 4x plus 1. And then on the right-hand side, that's -2 to the power of 3. That will work out to be -8. And then, again, you are just left with a simple 2-step equation here. I'm not going to show the rest of the steps for solving that. But I will let you know that we end up getting a fraction for an answer here. So that answer is going to be -7/4, okay? Really easy to check that one in the calculator. Again, always getting into the habit of checking your solutions before you submit your work. Very good habit to get into. But these radical equations, I would say, are pretty straightforward. You just want to isolate the expression and then undo it, right? Here in this next one, I do want to talk about this one. The way that this is different from the other ones is that you have a variable outside of the radical, okay? And so we want to kind of talk about how you take care of that, all right? So the first steps are absolutely the same. We still just want to go ahead and get that square root expression by itself. So I'm going to go ahead and use some inverse operations to do that. I'm going to subtract x from both sides, okay? And that's going to simply leave me here with the square root of 31 minus 9x on the left-hand side, and that, of course, is equal to 5 minus x on the right-hand side. Since those are not like terms, I can't combine them, all right? Next, I want to go ahead and get rid of this square root, which, remember, we always get rid of a root by raising both sides to the power of the index. So because the square root's index is 2, we're going to go ahead and raise both sides to the power of 2. And on the left-hand side, what that's going to do for us is it's going to go ahead and leave us with the 31 minus 9x completely by itself. But then on the right-hand side, we have a binomial squared, okay? So that's something that you need to either remember the product formula for. It was the formula that went quantity u minus v squared, or it's something you need to write 2 copies of and FOIL out, okay? But regardless of how you get there, what you should be ending up here with is 25 minus 10x plus x squared, okay? So it's at this point that now you're just looking at a nice quadratic equation, and so the way you would want to continue this is, of course, by collecting all your terms on one side. So next I might just go ahead and subtract 31 from both sides, and then I'll knock 2 steps out here in one line. I'll just go ahead and get rid of that minus 9x on the left. I'll simply do that by adding 9x to both sides here, okay? And you'll notice that I'm lining these up so that when I take a look at what's going to go on the left-hand side, these are going to cancel, these are going to cancel, and it just leaves me with 0 on the left-hand side. And then I line these up specifically so that I can go ahead and take care of my constants, and then I can go ahead and take care of my x terms, all right? And so for my constants, it's going to be a 25 minus 31. That's going to give you a -6. And then for your x terms, that's going to give you a -x, and then plus x squared, okay? And so we have this trinomial there on the right-hand side. It might be a little bit easier for you to recognize what it is you're going to have to do next if you get into the habit of writing this in standard form, which I'll go ahead and do right here. X squared minus x is minus 6. And then this is actually a trinomial that factors, okay? And so to solve the rest of this, it just gets handled like a straight-up polynomial equation where we want to factor and then use zero product property. So I'll factor this into x plus 2 times x minus 3, and then we would go ahead and use zero product property here and find that our two solutions are going to be x is equal to negative 2 and x is equal to positive 3, okay? Now, as a word to the wise on this one, right? So any type of equation where x shows up outside of the expression, right? So in the case of this radical equation, x showed up outside of the radical. Later on, we might see x showing up outside of the absolute value expression or whatever expression you have. It's always one of those things where you want to get into the habit of checking your answers. But you know, if you are already into that habit just for any type of example, regardless of what kind it is, then that's not necessarily something you're gonna have to worry about as like special case where you absolutely have to check for extraneous solutions. Okay, so I would just encourage you to, across the board, always get into the habit of checking your solutions there. All right. Next type of equation we're going to take a look at here are equations with rational exponents. And so remember that a rational exponent is basically an exponent that is a fraction. Okay, and the way to solve that is right here. So it just says simply to raise each side to the opposite power. I'm not necessarily in love with the language there because opposite to me has a tendency to mean you know, opposite in terms of sign, right? So what we really want to say here is instead raise both sides to the reciprocal power, okay? And so don't forget that a reciprocal is basically, if you have a fraction a over b, the reciprocal is what you get when you swap the numerator and denominator. So the reciprocal would here be b over a. And the reason that we would want to raise both sides to the power of the reciprocal is, well, I'll just go ahead and show you here, right? So in this first equation, we have the quantity x plus 5 all raised to the 3/4 power, and that's equal to 8. We want to go ahead and solve this equation, and so what we'll do is we'll raise the left-hand side to the 4/3 power, which of course means I have to also raise the right-hand side to the 4/3 power. Why would we do that? Well, because whenever you take a fraction and you multiply it by its reciprocal, you just multiply the numerators and multiply the denominators. So this would simply be 12 over 12 as the exponent on the left-hand side, or in other words, just 1. And so that is how we get the expression that we were raising to the power completely by itself, because technically this is this expression raised to the first power, but anytime we have an exponent of 1, we don't typically write that. So that's how we're going to go ahead and get that expression isolated. And then the only thing left to do there is figure out what's going on there on the right-hand side. That's something you could easily use a calculator for, 8 to the 4/3 power. The calculator will tell you that that's simply going to be equal to 16, okay? And then one last step there, just simply subtract 5 from both sides, and then the answer here would be x is equal to 11. Okay, so pretty straightforward to solve an equation with rational exponents in it. It's going to be the exact same thing here on this side. However, we are going to need to remember some rules dealing with rational exponents here. So when I raise both sides to the reciprocal here, what I'm going to do here is I'm going to raise it to the 3/2 power. And that's fine. That's what we're going to need to do. But we are also going to have to remember that the power that we're raising both sides to is a rational exponent itself, and the denominator is an even number. Okay, so if you remember our video covering rational exponents, what that's going to mean is that we need a plus or minus whenever we evaluate this. So when I do the right-hand side, the 25 to the power of 3/2, I'm going to need to remember that this is going to need to be something with a plus or minus in front of it. And if you were to plug that in the calculator, it would simply tell you that you just end up here with 125. So we're going to say plus or minus 125. So always be on the lookout whenever you raise both sides to a power that's a fraction and the denominator is an even number. You're going to need to remember that plus or minus. And then we know what happens on the left-hand side. We're just going to be left with the expression x minus 4. And then when you bring the 4 over, which I'll just go ahead and do by adding, since I went ahead and added 4 to both sides, that means that there's now a positive 4 on the right-hand side. So I'm going to write that as 4 plus or minus 125. And since these are nice integers, we can go ahead and figure out what our solutions are here pretty easily, right? So if you were to go ahead and add them together, you would of course get simply 129 as your answer. If you were to subtract them, you would of course get negative 121. And again, these are always solutions that you want to get into the habit of checking, which again is pretty easy to do in the calculator. Okay, so when you have a rational equation, it's very simple to do. You just want to go ahead and raise both sides to the reciprocal power, and then if the denominator of the power you're raising to is even, just remember that plus or minus out front. The next type of equation is equations with fractions in it, or in other words, rational expressions. And these are pretty easy to deal with. What we want to go ahead and do here is apply a method called clearing the fraction, okay? And so what you see here is you see this divided by x in the problem, and you also see this divided by x minus 2 in the problem, okay? It's these denominators that are making the problem a little bit more difficult than we would like. And so the way we get rid of division, of course, is we go ahead and multiply. So what I'm going to do is I'm going to multiply the entire equation by x, because that's my denominator right here. And I'm also going to go ahead and multiply times that expression x minus 2, not plus 2. There we go. X minus 2, because that's going to get rid of this x minus 2 right here, okay? And what I want you guys to always remember is that this is something that is going to get distributed to each term in your equation, okay? And so when we do that, when we distribute that to the first term, what's going to end up happening here is the divided by x is going to cancel out with the times x out here, and it's simply just going to leave you with 2 times what's left over out here, which is going to be 2 times the quantity x minus 2, okay? That's how this is going to work out whenever you distribute that to the inside. So I'll write that here, 2 times x minus 2, all right? Next, we'll go ahead and distribute what we have outside here to the middle term, and what's going to end up happening there, of course, is that this divided by x minus 2 is going to cancel with this times x minus 2 out here, and you're simply going to be left with what's left over. So that's going to be 3 times x that we'll go ahead and write here as what's left over in our next term. So I'm going to say equals 3x, and then, of course, whenever we go ahead and distribute this to the last term, we're just going to go ahead and write 1 times that, which is just, well, that, right? So we'll go ahead and write that out here, all right? And so you can see what that does. Whenever you multiply the entire equation by, this is called the LCM of the denominators, the least common multiple, okay? Some people call this the least common denominator. That would be the same thing, but I'll just say that here, the least common multiple of the denominators, okay? Basically, you look at all of your denominators and you write outside what it would be to get rid of those denominators, right? So since we're all doing division, we're going to do times. So now we're left with this polynomial equation essentially, and the next step, of course, here would be to go ahead and distribute. So on the left-hand side, we've got 2x minus 4. When we distribute that 2 in, on the right-hand side, pretty straightforward here as well. The only thing that you're going to have to, of course, remember is that you are dealing with a negative x here, and so when we distribute that in, we're going to need to change the signs. Okay, so negative x times x is negative x squared. Negative x times negative 2 is going to be a positive 2x. Okay, looks like we got some like terms there on the right-hand side, 3x plus 2x. I'll go ahead and attempt to write this in standard form here, so that'll be negative x squared plus 5x when you combine like terms. And we still have our 2x minus 4 on that side, the left there. And so what I'll go ahead and do here is simply just combine some like terms here. I'm going to go ahead and bring everything to one side so that it equals 0. Remember, that's how we solve our polynomial equations. And I'll go ahead and knock out 2 steps here in one line. So I'll go ahead and also add the 4 to this other side here as well. And that's going to leave us with 0 on the left, and that's going to be equal to negative x squared minus, sorry, not minus, plus 3x plus 4. And then before you you solve this polynomial, you want to go ahead and see if it's factors. And so what we always need to look for is a greatest common factor. Here, that is going to be a negative 1. So we'll factor that out, leaving behind x squared minus 3x minus 4. And then that is a polynomial that can factor itself. So I'm going to go ahead and factor that into the product of 2 binomials, x and x. And then that's going to be plus 1 and minus 4, in which case we're going to get our solutions here pretty straightforwardly, right? So 2 solutions. And these are something, again, I would like you guys to be taking the calculator and checking for yourself just to make sure you have the right answer before you submit that question, okay? So again, pretty straightforward. Whenever you have an equation with some fractions in it, you just want to clear those fractions by multiplying times the LCM. And then the last type of equation I want to review how to solve here in this video is how to solve equations with absolute values in it. So it says to write 2 equations, 1 positive and 1 negative, all right? I always find it easiest to make sense out of absolute value equations by going back to the definition of absolute value. And absolute value's definition is a number's distance away from 0, okay? And so what we are saying here in this example is that we've got this number, this x minus 2, and this is not a number that we know the value of. However, we know that its distance away from 0, which is what these bars mean, we know its distance away from 0 is equal to 3 units away from 0. So on the number line that I just drew here, if I draw 0 and then I count 3 to the right and I count 3 to the left, then I'm going to be sitting at either positive 3 or negative 3. And that's why this number in the middle of the bars that I didn't know the value of, I know that it's either going to have to be a value of 3 or it's going to have to be a value of negative 3, because those are the only two numbers on the number line that are a distance of 3 units away from 0. All right? And so that's exactly what we're going to go ahead and do. We're going to go ahead and take these two candidates for what that mystery number could be, and we're going to say that that mystery number could be equal to negative 3 or it could be equal to positive 3. Now, what did that mystery number look like again? Oh yeah, it looked like x minus 2. So we'll say that. We'll say x minus 2 is either equal to negative 3 or x minus 2 is equal to positive 3. Again, because in the equation it says that the distance away from 0 for that number is 3 units. So these are the only two candidates that could be possible. And then these are just simple one-steppers. I'll just simply solve these by applying the inverse operation to both sides. And we're going to get two solutions here. So on the left-hand side, we're going to get x is equal to negative 1. And then on the right, we're going to get x is equal to 5. Okay? And so two solutions for this absolute value equation here. These are two that you could go ahead and simply plug in to make sure give you that distance away from 0 of 3. And anytime you guys have an absolute value equation, it's oftentimes easiest to, again, go back to that definition of the number line and use that distance away from 0 argument with a picture. Okay? So that's it for this video. I hope that it has been of some help to you. If you guys have questions, feel free to let me know. But again, solving these various types of equations, there's different methods for each, but a really, really good method to always remember is this right here. Whatever the thing is, I say quote-unquote thing, but that could be a radical expression. That could be an absolute value expression, right? Always a good idea to isolate it using your inverse operations and then undo it either using an appropriate power or by using the definition, okay? So, again, I hope this video has been of some help to you. If you guys have questions at all, feel free to let me know. But that's all I got for this video. Thank you very much for your attention, and I will speak to you guys in the next one.